Hey there, Longhorns. It's Miss Campbell, and today we're going to learn about classifying triangles and also isosceles and equilateral triangles. So the first thing, classifying triangles, you have two ways that you can do that, and it's either by their sides or by their angles. So the first one I'm going to talk about is by the sides. Our first kind here is if you have sides that are all different. So let's say that this is 5 here, this is going to be 8, and this one can be like 12, right? So 5, 8, 12. None of these sides are the same. So this is what we call scalene. Okay, all different sides. So different sides. Okay, that's scalene. Our other kind of sides that we might have would be if they are all the same. So they're all marked with one dash, right? So all the same, that's going to be equilateral. Okay, same sides. So all three have the same length. And then our last kind of side classification is if you have two sides that are the same. And this is isosceles. Okay, and isosceles is two equal sides. Okay. And then our next kind that we have is by the angles. So now by the angles, all right, let me make my line a little smaller here. Okay. By the angles, here you see if you have one angle that's greater than 90, so let's say this is like 100, right? One angle that's greater than 90, that is obtuse. So one angle greater than 90. Okay, greater than 90. Our next kind of classification with angles is if you have a right angle, then it is a right triangle. Okay, one right angle makes it a right triangle. One right angle. Okay, and then let me fix that here. Okay, one right angle. And then over here, our last kind is if you have three angles that are all acute. So this one can be like 60. This one could be 50. And then this one can be like 70. Yes. Okay. So all three are less than 90, then it's an acute triangle. All three less than 90. So let's review that. If you have no sides that are the same, then it's scalene. If you have all three sides are the same, it's equilateral. If you have two sides that are the same, it is isosceles. Now with the angles, if you have one that's greater than 90, it's obtuse. If you have one that's exactly 90, then it's a right triangle. And then if you have all three less than 90, then it is an acute triangle. Okay, so our next item that we're going to talk about is the isosceles triangle, okay? So this is an isosceles triangle, all right, which means that it has two equal sides. So two equal sides. And those two equal sides are called the legs, okay? The two sides that are equal, and you can tell they're equal by these tick marks. The two equal sides are called the legs. And then you have these two angles here at the bottom. Those are congruent. Those are called your base angles. So your base angles are the two congruent angles. So for an isosceles triangle, in order for a triangle to be isosceles, you're going to have two equal sides, which means that you have two equal angles. I also want you to notice, I'm going to change colors here, that your equal sides and the equal angles, you see they're diagonal from each other. Okay, the equal sides are across from the equal angles. That is important as we go forward here. And then the last part up here is this vertex angle. Okay, your vertex angle is that one angle that's not the equivalent one, so it's going to be different. Okay, and then here now we'll compare isosceles and equilateral. So isosceles, like we said, we've got two congruent sides, which means that you have two angles that are congruent to each other. All right, and then here, equilateral. Equilateral, remember that means three equal sides. Okay, and so since you have three equal sides, guess what? You're going to have three equal angles. Okay, so three equal sides, three equal angles. Okay, and another way to phrase this three equal angles is to call it equiangular. So like equilateral, the lateral part talks about the sides. Equiangular talks about the angles. So equilateral triangles are equilateral and equiangular. And a thing to note about equilateral triangles, guess what? All three angles in a triangle add up to 180, right? So all three together is 180, but all three of them are the same. So we're going to take 180 and divide it by 3. Automatically, whenever you see an equilateral triangle, each angle is 60. So each angle is 60 degrees. So all angles are 60. And then again, with our isosceles, we have two congruent sides and two congruent angles. And remember, congruent means equal. Equal means congruent. Okay. So now let's get into some problems here. There is a theorem here. It's called the base angles theorem, and this goes with isosceles, okay? This goes for isosceles here. If two sides of a triangle are congruent, then the angles opposite them are congruent. Okay, so look on our picture right here. It says we need to find the values of x and y. All right, so we have two sides of our triangle congruent, right? So if two sides of our triangle are congruent, then the angles that are opposite from those sides are going to also be congruent. So you see here the side, I draw this arrow across, okay, that's what we mean by opposite. Those two angles are going to be congruent. So we need to take the equations, the expressions here, I'm sorry, and set them equal to each other. So we will have this 7x plus 2 is going to be equal to this 8x minus 7. And then we just need to solve this for x. I'm going to take my small x, which is the 7, over to the big one. So I'm going to do minus 7x minus 7x. So I get 2 is equal to x minus 7. And then now I just need to add 7 to both sides. Okay, and so I get that x is 9. Okay, and how did I know that? Because I see I have two equal sides. The angles opposite from them are going to be equal then. So just set them equal and solve for x. Okay, the next one that we have here, again, we see two equal sides. So those angles across from them are going to be equal to each other. So this 2x plus 4 is going to be equal to this 4x minus 22. Let's solve for x. Take my small one over to my bigger one. So 4 is equal to 2x minus 22. Add 22 to both sides. So I get 26, and that's equal to 2x. Divide by 2. So x is 13. Okay, now I'm not quite done. In order to find y, I have to actually take my x value and plug it in to one of these two angles, because if I know one, then I know the other, because they're congruent. Okay, and then I'm going to use the fact that all three angles have to add up to 180 to find y. So I'm going to do that in a different color. Okay, so I'm going to do 2. I'm going to plug into this 2x plus 4. 2 times 13 plus 4. So 2 times 13 is 26. 26 plus 4 is 30. So each of these angles is 30. Now how do I find y? Well, y is going to be equal to 180 minus these two angles, which are each 30. Okay, so what's 180 minus, and then 30 and 30 is 60. 180 minus 60 is 120. So that's how we find y. All right. Next example here. Now we're going to go the reverse way. Now they're going to tell us that we have two congruent angles. So if two angles of the triangle are congruent, then the sides opposite them are also congruent. So now we're going the other way around. We have two congruent angles. That means those sides across are going to be congruent. So in example 3 right here, this 5x plus 7 side is going to be congruent to that 42. And you'll see I added these tick marks there to show. So 5x plus 7 equals 42. Well, take away 7. So I'll get 5x equals, and 42 minus 7 is 35. So just divide by 5. So x is 7. Okay, now we'll go back over here to our other problem. Again, we see we have two congruent angles. So those sides across from them are going to be congruent. So we set them equal. So 8x plus 19 is going to be equal to this 12x plus 3. I'm going to take my smaller x over to my bigger one. So minus 8x minus 8x. 19 and 12 minus 8 is 4, so 4x plus 3. All right, take this 3 over to the other side, so I have to subtract. So 16 is equal to 4x. Divide by 4. So x is 4 for this one. And again, how did I know to write these equations? Because I see that I have two angles that are congruent, so those sides across from each other are congruent. That's the corollary, or the converse, I'm sorry, of the base angles theorem. So we're just reversing it. Remember, converse is reverse. All right, next one we have here. This is the corollary to the base angles theorem. So this is now where we go into that equilateral triangle thing here. So an equilateral triangle is kind of like an extension on that isosceles, and the fact that now we have all three sides congruent. So it gives us a little bit more with our angles. So if a triangle is equilateral, then it is equiangular. Okay, so we see three congruent sides. So that automatically tells me all three of my angles are the same. And here, that's 60. Remember, where does that 60 come from? 180 divided by 3, which is 60. Because if all three are the same and they all have to add up to 180, they each have to be 60. So now 5x plus 25 has to equal 60. So take away 25 from each side. So 5x is 35. Divide by 5. And so x is 7. All right, there we go. Okay, we got just a couple more here. All right, again, now here, we're going to do the converse of it, all right? If a triangle is equiangular, then it is equilateral. So if we see 3 equal angles, guess what that tells us? We have 3 equal sides, okay? So now I see these, the 3 equal angles, that tells me the 3 sides are the same, so I can take these two expressions and set them equal. 6x plus 16 equals 9x minus 11. Take my small x over to my big X. So 16 is equal to 3x minus 11. Add 11. So I'll get 27 is equal to 3x. Divide by 3. So x is 9. All right. And then it says find the perimeter of the triangle. So we have to actually go one step further here. We have to plug in x is 9, and then we'll know all 3 sides because they're all the same. And then we're going to find that perimeter, which you have to add the 3 sides. So I'm going to do 9 times 9. I'm plugging into this 9x minus 11. Okay, minus 11. So 9 times 9 is 81, and 81 minus 11 is going to be 70. Okay, you can check it over here. Do 6 times 9 plus 16. Well, 9 times 6 is 54. Add 6 to that, you get 60. Add 10 more, you get 70. So if these two sides are 70, guess what? My third side is 70. So the perimeter is going to be 70 times 3, which is 210. That's the perimeter. Okay. Then we have our last 2 problems here. All right. Okay, on this one, we can see we have 2 congruent sides. So what does that tell us about these angles here? That they are also congruent. So this 5x minus 12 is going to be equal to this 3x plus 26. All right, let's solve. Minus 3x minus 3x. 2x minus 12 equals 26. Add 12. So we get 2x equals 38. Divide by 2. So x is 19. Okay, and that's what they want us to do. They want us to find x and y and z on the other problem. Okay, so x is 19. Now we have to actually plug in here so that we can then use that information to find y. So we have to do, let's do 3 times 19 plus 26. So 3 times 19 is going to be 57 plus 26, you get 83. So if this angle is 83, then that means this angle is also 83. How do I find 2y? Well, 2y plus 83 plus 83 has to equal to 180. Okay, so let's just add those together. 83 times 2, give me 166. So 2y plus 166 equals 180. So 180 minus 166 is 14. So 2y equals 14. So divide that by 2. So y is 7. Okay. So there's that one. Last one. Y'all have been troopers, making it through here. All right, let's do our last one, and I'm going to draw us a nice line to separate our problems, and we're going to change our pen color. Okay, make it a little bit thinner. All right, let's draw the last one. We see here we have 3 congruent sides. So what does that tell us about our angles? They're all congruent as well. And if all 3 angles are the same, what do we automatically know that they are each equal to? 60. So each angle is 60. All right, so we're going to have 5x plus 25 equal to 60. Okay, so minus 25, minus 25. So 5x is 35. So x, we divide by 5, so x will be 7. Okay, and now here, 32z minus 4. Guess what? That's also going to be equal to 60. So add 4. Add 4. So 32z is 64. Divide by 32. So z is going to be equal to 2. And then our last part, this one's really quick. 4y is also equal to 60. So divide by 4, divide by 4, y equals 15. All right, guys, so there you go. That's how we work with isosceles and equilateral triangles, and I'll see you guys in the next one.